Chemical bonding. So it's a very important concept in chemistry, and we will explore it into the details. Without knowing the bonding, we cannot understand the chemistry. Chemistry is basically starting with the bonding, and when two atoms join together, it's because of the bonding. Bonding, when we see one atom and another atom, there is a bond between them. Okay, this is a line. So in reality, it does not mean that there are two atoms and there is a stick in between them. So this is just expression. The stick or the bond or the line uh, is just expression that the two atoms are joined together or are in a relationship. It's just like a human relationship, like a husband and wife. There is not a stick or any door between them, but there is emotional connection between them, and that emotional connection, that is love, is some sort of bonding. Similar in the chemistry, it's just a it's just a force, nature force between the two atoms. Okay, that is bonding. Now how it this force express itself in different forms. There are different types of bonding. For example, between the two atoms there is a bonding of two types. One is called the covalent bonding, another is called the ionic bonding. And the two types of bonding is basically manifested because of two different characters of the two metals. For example, the 1s or the 2s elements are called the alkali or alkaline metal. They want to gain a comfort, satisfaction, or stability, whatever we can say in terms of scientific way or social way, we can say satisfaction. Okay, so they have a two or one or two electron in their the last shells. Okay, and they don't want two electron or one electron in the last shell. Rather, one alkali or alkaline metals, and that is S block or the P block, they all want 8 electron in their last shells. So if they have 7, definitely that is the non-metals or in the P block, they usually they have 7 or 6, so they cannot lose 6 or 7. So they want to get 1 or 2 to complete their 8, to get satisfied. When they get 8, they get satisfied. Okay, and the alkali metals 1s or 2s, when they release 2 or 1 electron, that is alkali release 1 electron and the alkaline release 2 electron, they become satisfied, they become happy after releasing. Okay, because it's extra thing. Okay, they are not greedy to keep the 1 electron in the last shell, rather they want to emit. Okay, so when the alkali or alkaline metal, alkali emit 1 electron or alkaline emit 2 electrons from their last shell, the remaining shell is 8. In the remaining shell, there are 8 electrons. So they become happy and charged as well. And after the release, there is a charge. Their force is developed on their surfaces. Okay, then where this extra electron went? It went to the non-metals. Okay, or for example, chloride or fluoride, whatever. So they get that electron and complete their last shell. So they also become charged. And when charge is developed, then the force is developed. And that force of attraction is called the bonding, basically. Okay. So this is the ionic bonding. But another bonding, that is covalent bonding. In that bonding, the metals, certain metals or certain, for example, the top, the electron is shared by those metals which are not greedy or which are not miser at all. Okay, so they don't want to keep the electron, they just release. There are certain other metals, okay, that are not so generous. Okay, for calcium is generous as well, at some time it's not generous, the upper part. And the boron is sometimes generous, sometimes not generous. So those metals which are not so generous to release completely their electron, they keep the electron, but they want to complete their octet. Okay, the 8 electron. So they shared electron. And because the non-metals, they always want to complete the 8 electron in the last shell, and if they don't get free electron, the completely electron, so they say, oh, it's okay, just sharing is okay. Okay, this like couples who spend equally in the homes. Okay, and they feel happy like this. So this nature has created different the materials, the elements. Okay, so this is the bonding. When one is sharing, another is sharing, the actual goal is to complete the octet and get satisfaction or the stability in a scientific way. Okay, so that's the covalent bonding, and that is between the two atoms, or okay, or three atoms, whatever is a localized. Okay, but another bonding that is that is not localized, that is rather in the bulk of the material, that is in the diamond or in the graphite. The one, that covalent bonding is not just limited to the two atoms, rather it is spread across board. Okay, that's why the diamond is very hard, because bonding is spread across board, covalent bonding. And the chlorine or HCl is a liquid or gas, because its bonding is just between the two atoms. It's localized. And that's why the silica is also very strong, a very strong melting point is very high and very hard, because the bonding, covalent bonding is spread across the board in bulk material. And another bonding is called the metallic bonding. That is also not localized between the two atoms. Rather, for example, if you see the sheet of the gold or the silver or any metal, it is very hard sometimes. Sometimes not very hard, even soft, but it's not melted at certain temperature. Okay, it's not low temperature. So most of the metal are hard, they have ductility property, and that is because the metallic bonding. Metallic bonding does not allow them to become a liquid at room temperature, although there are some exceptions like mercury, but usually the metals have very strong, they are hard and boils at or melt at very at high temperature. That because of the metallic bonding, because in the metallic bonding there is extra electron are released into the joint account of all the metals. It's like it's the national account. Okay, all the people have a individual account, but they have a national account, and in which this they just keep their extra money. So similarly, when there is a metal sheet, so for example sodium metal sheet, so there are one electron in the last shell, and all the sodium atom don't want to keep that electron, that become free, and that is, but it does not go out of the sheet, it just remain in the sheet, but it is the shared electrons of all the atoms in that sheet, and that's why become the that create a positive center and the negative center. Positive center because of the positive charge on the metal, because the protons are there in the center, and the negative c of the electron. So that's the two forces attract and keep the metal in a shape or in the form of a solid form. Okay, that is the metallic. That is not just limited to two atoms, it's rather spread over whole community of that ions. So that is the metallic. So these the bonding basically makes the materials, and arrangement of the atoms in different shapes or in different forms actually is because of the different. For example, the diamond has a different structure, four with the four bonds, and the graphite have a three bonds, and one is another is the one electrons create a the one electron is free, and then those free electrons join together to make surfaces in the graphite. Okay, that's why the graphite layers are slippery. Okay, and we can write with the graphite pencil. Okay, the carbon pencil in on our copies on notebooks. So that's why the bonding is the fundamental phenomena that we need to understand to go into the deeply into the chemistry. So that's our message or that's our subject of the day. Thank you very much. And we will come up with the next few more lectures every day. But this is not actually lecture series. This is just a talk. So if you when you are listening this or reading watching the videos, just take it easily. Understand the things from your mm, from in a casual way. In this way, you learn the better way. Okay. Thank you. Have a good day.